Alright guys, for today's lesson we're going to talk about one, I'm not going to say one final, but another differentiation technique, and that's the idea of implicit differentiation. And I know that sounds like a complicated word, but it's not. The word implicit differentiation is basically the opposite of what we call an explicit differentiation. And explicit differentiation is technically what we've been doing. If you notice, all of our functions that we've been taking derivatives of have been set equal to one variable, y, namely y. So like all of these, you could easily take the derivative of. So these are explicitly solved for the variable y. The implicit function is one that is not specifically solved for y. So for example, if I want to take the derivative of x plus y is equal to 7, if I wanted to find the derivative of that, how would I do that? So that's what we're going to be looking at now. Now, obviously, with this function, if we tried to take the derivative of this function, you could easily say, well, I can solve this for y. If I solve this for y, I would get y is equal to negative x plus 7. And so then the derivative of y with respect to x would just simply be negative 1. Well, that's easy. So then I can just take any function to solve it for y and call it a day. Well, some functions you can't do that so easily for. Like, let's say you had let's say I had x plus y cubed is equal to 14 y plus 7. That would be very difficult to solve for y, and then on top of that take the derivative. So there has to be a better way, a quicker way to take the derivative. And since we're right here, let me show you how easy it is to take the derivative implicitly. What you do is you just take the derivative each section at a time. And remember, you're trying to find, if you want to find the derivative with respect to x. So if I wanted to find the derivative of x, well, what's the derivative of x? It'll just be 1. It'll be 1. And what did you do? You took the derivative of x. So you took the derivative of x, and what did you take it? What did you take it? What did you take it with respect to? You took it with respect to x. So you took the derivative of x with respect to x, and that's the symbol that represents it. So you had the derivative of x would be 1 dx dx. All right. Well, what's the derivative of y? The derivative of y would also be 1. And you took the derivative of y, so you took y, and what did you take it with respect to? Well, you took it with respect to x. And then what's the derivative of 7? Well, you know the derivative of any constant is just 0. And so since you're trying to solve this for dy dx, can't we simply just say, oh, well, dx over dx is just 1, so this is just 1 plus y dx is equal to 0. And can't we just solve this for dy dx? And I get dy dx is equal to negative 1. Well, look there. So you get the same answer. So that's how we're going to take the derivative implicitly. We're going to take the derivative of each section of our problem, and then we're going to solve for dy dx. Okay, now that one was a simple one, but let's take it up a notch. So let's say that you had the function y cubed plus y squared minus 5y minus x squared is equal to negative 4. My goodness, could you imagine having to solve that for y? It would be dang near impossible to try to solve that for y and then take the derivative of that. So instead, let's take the derivative implicitly. Let's take the derivative of each part. So the derivative of y cubed would be 3y squared, and notice you took the derivative of y with respect to x. The derivative of y squared, so that would be 2y dy, you took the derivative of y with respect to x, minus 5y, so the derivative of that would be minus 5, and you took the derivative of y with respect to x. The derivative of negative x squared would be negative 2x, and you took the derivative of x with respect to x, the derivative of any constant is 0. Now, here's my suggestion to you. Once you get that done, what you want to do is you want to keep all the dy dx terms on one side and move the non-dy dx term over to the other side, and keep in mind dx over dx is the same thing as 1, so it's just 1 times negative x, that's negative 2. So, all right, now, on the left-hand side, you notice they all have dy dx in common, so I'm going to factor that out, and that leaves behind 3y squared plus 2y minus 5. equals to a positive 2x, and then to solve this dy dx, I'm just going to divide both sides by that, so that's where I get dy dx is equal to negative 2x over 3y squared plus 2y minus 5. There's my derivative. So it's not too difficult to do. Just remember to take the derivative at each part. All right, let's take a look at another one. Let's say that I wanted to find the derivative implicitly of x squared plus 4y squared equals to 4. So the derivative of this would be 2x dx dx plus 8y dy dx is equal to 0. Sorry, derivative of 4 is 0. Remember, dx over dx is the same thing as 1. Keep the dy dx term alone and move the other one to the other side, and then that would give you dy dx equals negative 2x over 8y, which technically reduces to negative x over 4. All right, now, I want you to find the slope at the point radical 2, negative 1 over radical 2. Now here is where I'm going to have to use my derivative and plug in those values. So I'd get for x, negative radical 2. And for the first time, we actually are going to plug in a value for y, which would be negative 1 over radical 2. So that gives me negative radical 2 over negative 4 radical 2. And I know from pre-calc you wouldn't leave it like this, so I'm going to day change flip, so I get negative root 2 times root 2 over negative 4, so that gives me negative 2 over negative 4, so that reduces to 1/2. So I found was the slope of my function at that point is a positive 1/2. So it took me a little pre-calc to do that also. All right, let's take a look at another one. So let's say that I had the function of 3, and then this is x squared plus y squared, and that squared equals 100xy. Wow. So I want you to understand, take a second look at this. This is not only going to be the product rule over here because it's x times y. It's also going to be the chain rule right here because I have this function inside of that square. So this is going to be a very complex derivative. So let's do it really quickly. So remember, take the derivative of each part. So over here, this is one whole unit. The derivative of this would be, by the power rule, 6, leave the derivative, leave the inner function alone, off the outer power, so it's 1. Now take the derivative of the inside. So the derivative of the inside would be, and notice I didn't take the derivative of any variable when I did the power rule, right? It was just 3 times 2 is 6, leave the inside function alone. No derivative of a variable, but now I will. The derivative of the inside term would be 2x, and that would be derivative of x with respect to x plus 2y, derivative of y with respect to x. So there's it for that. Equals, now over here, I'm just going to treat this as my first term, and this is my second term. So I'd have first, 100x times derivative of the second, dy dx, plus second times derivative of the first, which would just be 100. Don't forget that dx dx. So there is my derivative. Now, I'm just going to take this up a notch. Let's say I want you to find the value of my derivative at the point 3, 1. Now, if that's the case, I wouldn't waste my time trying to solve this for dy dx. I would just go ahead and plug in those numbers. So I'd have 3 squared plus 1 squared, and this is 2 times 3, and you know that dx dx is just 1 anyway, plus 2 times 1, and y dx is what we're trying to find. That's my slope, equals 100 times 3. Again, dy dx is what you're trying to find, and then plus 1 times 100, and you know that dx dx is just 1. But doing arithmetic, I'd get 3 squared to 9 plus 1 is 10. 10 plus 10 times 6, that'd be 60, times 3 times 2 is 6, that'd be 6 plus 2 dy dx equals, and then over here I'd get 300 dy dx plus 100. I'm going to go ahead and distribute, and that would be 360 plus 120 dy dx is equal to 300 dy dx plus 100. And then I'm just going to subtract 100, so that gives me 260 over here. Subtract 120, that would give me 180 over there. And again, I'm trying to solve for dy dx, so I'm just going to divide both sides by 180, so that gives me 26 over 18. And if I reduce that, that gives me 13 over 9, and that would be the value of the derivative at the point 3, 1. All right, let's look at one final one. Let's say that I wanted you to find the tangent line to the graph of this function, x squared times x squared plus y squared equals y squared at the point, oh my goodness, this is rough, radical 2 over 2, so radical 2 over 2, comma, radical 2 over 2, which hopefully with these squares that help clean it up a little bit. Anyway, let's start off by taking the derivative. Now, again, there's two ways of doing this. You could just go ahead and distribute that x squared. In fact, I might actually do that. Or you could do the product rule, right? First times the derivative of the second, a second times the derivative. It's up to you. What I'm going to do is I'm just going to go ahead and do the algebra. I'm going to distribute this first, and so that'll give me x to the 4th plus x squared y squared equals y squared. And now I'm going to take the derivative of this. So the derivative of this will be 4x cubed dx dx. All right. Plus now the product rule should be first times derivative of the second, which would be dy dx, plus second times derivative of the first, which would be dx dx. That's it, equals 2y dy dx. And now, again, I'm going to try to solve this for dy dx. I'm going to go and plug in my values. So I'd have 4, and then x, that would be radical 2 over 2 cubed, and I know that that's 1. So plus, and then radical 2 over 2, 2 times radical 2 over 2, dy dx, plus, my goodness, there's a lot of radical 2's over here, times 2, radical 2 over x, and then that's equal to 1, equals 2, radical 2 over 2, dy dx. All right, let's hope that some of this stuff will clear out. All right, so over here, if I multiply this, I would get 2 radical 2. So then that would be 2 radical 2, so that would just be 4 radical 2, plus, that would be 2 times 2 is 4, so that would be just 1, so it would just be dy over dx. And again, pause the video and do the arithmetic if you need to. And then over here, that would give me, that would just cross out, so that would give me 2 radical 2 over 2, so that would just give me radical 2 equals, that would give me radical 2 dy dx. And so then what I would do is I would subtract the dy over dx, and then that would give me 5 radical 2 is equal to, and if I subtract 1, so that's going to give me, I'm going to go ahead and factor it out, dy over dx, and then that would be me radical 2 minus 1, and then I would divide that, and then that would give me 5 radical 2 over radical 2 minus 1, and that would give me my slope there. That would give me my slope.